nice. Okay. First of all, you should know that there's something called a sample space. And a sample space is the set of all possible outcomes. So like, for example, oftentimes we talk about rolling dice, 2 dice, and the sample space are all the different combinations that could come up, which would be a total of 36. And so those 36 possibilities is your sample space. And then an event is an outcome or a set of outcomes within that sample space. Usually they use capital letters like A, B, C, maybe X to represent that event. So maybe you could say something like, what's the probability of rolling a sum of 5 when you roll 2 dice? And that would be your event or outcome. And then a probability model is the description of that chance that has 2 parts, the sample space and the probability for that outcome. So for example, imagine that you're rolling 2 fair die. And they're 6-sided, one's red, one's green, and here are all the 36 possibilities that you see on the screen. If you're talking about the probability of event A, that is rolling a sum of 5, you would see it listed as P of capital A. And then you find out which ones are those things. So as I look at the probability of rolling a sum of 5, I look for all the things that add up to 5. So for example, it looks like here's a 5. Oh, jeez. Sorry. So here's a 5, here's a 5, here's a 5, and here's a 5. For a total of how many things? 4 out of the 36. So you would write down that probability is 4 out of 36, and please always simplify, so that would be a total of 1/9. And if you want to, of course, you could write this as a decimal. If you divide that on your calculator, you'll probably get 0.1 repeating. You may write probabilities as fractions or decimals. No big deal. Try not to use percentages unless they ask you in the question, what's the percent? Otherwise, use a decimal or a fraction in simplified version. What's the probability of not rolling a sum of 5? Of course, that would be everything else. So since we already know that the probability of rolling the 5 was 4 out of 36, that means that we have 32 out of 36 left over, and that would be a total of 8/9. And if you wanted to, you probably could have said, oh, I know that all the probability out there totals, if it's a fair event that could happen, totals 1 for the total sample space. So I could have thought of it as 1 minus 1/9 to get that same 8/9 as my answer. Okay, and that's called the complement that we'll talk about a little bit later. What do you notice about adding up the 2 probabilities, the probability of A, which was 1/9, and the probability of B, which was 8/9? Equals 1. So whenever you're talking about a total space, total sample space that you could have, your probabilities, if there are fair events that are occurring, should always total 1. That's a way to check to see if this is indeed a true probability. So they have to total 1. All possible outcomes. All possible outcomes must total 1. In the next part, the event C, they talk about rolling a sum of 6. So I go back and again, I look in my diagram of where are all the 6s. And so if I look for all the 6s, 5 and 1, 4 and 2, 3 and 3, 2 and 4, and 1 and 5. So I know that my probability of rolling that 6 for a total sum would be, how many were there? 5? 5, bless you, out of the 36. And then, when you are looking at the word or, this word or, in a probability where it's you have a set of outcomes, really means plus in mathematics. So as I look at what's the probability of A or C happening, what I would do is I'd look at whatever the probability of A was, which was 4 out of 36, and I would add that to the probability of whatever C was, which was 5 out of 36, for a grand total of 9 out of 36, or in other words, a fourth, or 0.25 again if you like to write it as decimals. And later on we're going to talk about this OR with Venn diagrams, and you'll see how that pertains to the word or as well. In a Venn diagram, it means looking within both circles. Okay? The total sum between both circles. And then the word and means both have to occur in probability. So whenever you see the probability of A and C occurring at the same time, they're saying what is the likelihood that you're both going to roll a sum of 6, and at the same time, when you look at the dice, you're also going to see a sum of 5. 0 is correct. It cannot happen. So the answer is 0. It is impossible for you to roll 2 dice and see the 2 dice total 5 and 6 at the same time. That's what they call mutually exclusive. You cannot, there's no overlap in the Venn diagram when we look at the Venn diagrams coming up, and so that can't happen. And when that's true, then you write down 0. Okay, on our next slide, we have some basic rules of probability. First of all, we know that probability must fall between 0 and 1 inclusive. That means you could have a probability of 0, you could have a probability of 1, you never get negatives, and it could be anything in between. You can write them as fractions or decimals. In part 2, the probability of any sample space has to be 1. It has to total up to 1. In number 3, the way that you find a probability of an event is you look at the outcomes that you want, or sample A, or event A, I should say, or I sometimes talk about a success. So I want to see the sum of 5, that's my success. If I see that sum of 5, that's what I wanted. So what's the likelihood of that happening? You take that number divided by the total possibilities, and that's your probability. Something that's called the complement. You'll see this little C after the event. That means everything but that occurring. We talked about that on the previous slide in gray. So if I know that the probability of rolling a 5 is 6 out of 36, or a 7, excuse me, 6 out of 36, or 1/6, the probability of not rolling that 7 is everything else. That's called the complement. And a very easy way to find that is you just take 1 minus whatever the probability is of the event, and that makes it easy for you to find the complement. And that's what they're demonstrating in the red there, or underneath the red. And then the last thing is the phrase disjoint and mutually exclusive means that 2 events cannot occur at the same time, or in other words, they have nothing in common. And they have a rule for that. So if you know that A and B are disjoint or mutually exclusive, then the probability that one or the other can be found using this formula, which means that basically you add up the 2 probabilities. So in the previous example, we knew that the 2 sums, 5 and 6, were mutually exclusive, or in other words, disjoint, because we could just add their probabilities, and that was the probability of the or. Whereas when they overlap in a Venn diagram, which you'll see shortly, those are not mutually exclusive or disjoint because they share something in common. So that's what the word disjoint means, and I'll refer to that when we look at the Venn diagrams. In this next part here, in the example, they give us a table. These are actually the probabilities from AP Statistics, probably from last year's test, of getting a 1, 2, 3, 4, or 5. So as we look at, just for our own sakes, of what's the likelihood that we are, as a class, going to do well, by my definition of well, there's a 23.5% chance you'll get a 3, a 22.4% chance you'll get a 4, and a 12.5% chance that you're going to get a 5. So as you look at this, there's 65% roughly chance that you're going to get what I would call a passing score on the AP exam. It's a really good chance, and for us, we're probably going to be higher than that, but that's what they say statistically. So how do we show that this is a probability model? First of all, the first thing that I notice is that every probability listed is less than or equal to 1. That's the first thing that I look for. You can never have a probability more than 1. The second thing that I notice as I look at these probabilities is 0.233 plus 0.183 plus 0.235 plus 0.224 plus 0.125 equals 1. This is how you show that something is a legitimate probability model. 1, all scores are less than or equal to 1 and greater than or equal to 0. and 2 that their sum is 1. Next, let's find the probability that a student chosen scored a 3 or better. So I would say something like, if I'm writing this out as a probability, I guess, I would say the probability that the score is greater than or equal to 3. And I would just look at, oh wow, that's funny. I already highlighted that in purple. So 0.235 plus 0.224 plus 0.125, and whatever that total is, that's my likelihood. My sources say 0.584. So let me check my math on that. And then what's the probability that somebody scored a 2 or worse? You could, if you're doing this, do it this way. The probability that the score is less than or equal to 2, which would be equal to 0.233 plus 0.183, which would be a grand total of 0.416. Or, as we talked about earlier, since this is the complement, since they're mutually exclusive, you can say that the probability is equal to 1 minus 0.584, which would yield the same answer. So you can use your knowledge of the total sample space as 1 to do the same thing. And the readers of the test know that you can do either, especially since you found B already. In this next slide, we're going to talk about the probability involving 2 events. So sometimes